Okay, so we're going to factor this expression. It's got three terms in it. So the first thing we'll look for is the greatest common factor that could come out of all these terms. So hopefully we're all okay with the fact that each of these is an even number. So we'll take out, for sure, a 2. They all have an a term in them, so the question is, what a to the power of what do we take out of here? So put an a, look at the exponents, and decide which one is the lowest number. And in this case, lowest meaning also most negative. So the exponent that's coming here is negative 5 over 2. So that's our common factor we're going to take out. Now the million-dollar question is what's left inside the brackets. So from this first term, we've already taken out the 2. We need a to the exponent 4 over 2. Just to keep it with a common denominator, you can see that a to the 4 over 2 times a to the negative 5 over 2 would get me back to what I had in the question, which was a to the negative 1 over 2. Next, I'll have minus 2, because 2 times 2 will give me the 4, and I need a to the 2 over 2. Again, because once I multiply a to the 2 over 2 times a to the negative 5 over 2, it would get me back to what I started with, which was a to the negative 3 over 2. Last piece, minus 35. 35 times 2 is 70. I already took out the a to the negative 5 over 2, and so I can close that bracket. Now I'm not quite done, because I wouldn't usually write my exponents this way. The front term is good, 2a to the negative 5 over 2. Now, a to the 4 over 2 is just a squared minus 2a minus 35. Like any good math student, I'm going to look to see if it factors any further than I already have. I look for two numbers that multiply to give me negative 35, add to give me negative 2, and so the brackets, expression in the brackets, does factor a little bit more to say a minus 7 times a plus 5. Multiply those together if you like to check. A squared minus 2a minus 35. All done. Nothing left to factor. We're finished.